Baby Shawties, welcome to section 2 of chapter 10. Today we are going to look at the relationship between parallel lines and transversals, and specifically going to look at the angle relationships that we started to develop towards the end of section 1. So we talked last section about parallel lines as being two lines that are in the same plane. So say line M and line N that do not intersect. So we're going to say here in all these things we're going to look at that we have two parallel lines. So line M is going to be parallel to N. And then we're going to introduce a transversal. So a transversal is going to be a third line, call this line T, that intersects the other two at two different points. So there's a point there and a point there. So we're going to say here that T is going to be what's called the transversal. And what we're going to do is we're going to look at the angle relationships formed around those. Okay, we talked about different types of names. So note that when you have those two parallel lines in the transversal, there are 8 angles formed. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so last section we ended with talking about the special types of angles. We talked about corresponding angles, consecutive or same-side interior angles, as well as alternating exterior and alternating interior angles. What we're going to do today is we're going to look at those same angle relationships, but we're also going to start talking about what happens when those angles are formed between two parallel lines. So specifically, the main detail that we're going to add in today to what we talked about last time is that our lines are going to be parallel. Now, when the lines are parallel, that means these angles are going to form some special relationships. So we're going to start off first with corresponding angles. So again, corresponding angles are angles that are in the same location. So if I have my two parallel lines and my transversal, okay, so I'll label T as my transversal, and I have M and N. Corresponding angles are going to be angles in the same location. So to give you an example, let's say that I have my angle here and my angle here. Those angles are both in the top right corner of those two intersection points. So the example here I'm using, let's use kind of the numbers I had before, would be, for example, angle 2 and angle 6. Now, those are not the only pair of corresponding angles. You have 4 and 8, 1 and 5, 3 and 7 based on my drawing. But if my two lines are parallel, what it said is that these two angles, corresponding angles, 2 and 6, or any other pair of corresponding angles, that corresponding angles are always going to be congruent to each other. Congruent, again, means that they are going to be the same measure. So what you'll see here is that angle 2, for example, is going to be congruent to angle 6. So anytime we have corresponding angles, if our lines are parallel, that means that they're going to be congruent. Now, real quick, I should have drawn this at the beginning, but to show that these two lines are parallel, let me add in those arrows there. This is only going to be true. They're only going to be congruent if our lines are parallel. So again, we're going to be looking at the same relationships we ended with section 1, but now adding in what would happen if the lines are parallel. Okay, looking at our next one, same side interior angles. So again, the same diagram, it uses consistently over and over. I have line M, I have line N. So what we're going to look at is what happens if those two lines are parallel to each other. And then I have my transversal T, which obviously cuts across those. Same side interior angles, also known as consecutive. Know that the special name or formal name is consecutive. I like to call them same side interior angles. Those are going to be angles that are on the same side or same side of my transversal, but also between my two parallel lines in this case. So an example here would be, for example, angle 4 and 6. So both those angles are on the same side of our transversal as well as being in between the two parallel lines. So that would make angle 4 and angle 6 same side or consecutive interior angles. Now, what makes them so special? What is their property? What's true about them? So for same side interior angles or consecutive angles, they're not going to be congruent to each other, unlike corresponding angles. Okay, what makes same side or consecutive angles special is that they are going to add up to 180 degrees. So angle 4 and angle 6, it's this one kind of hard to visualize, but you'll see 4 is going to be an acute angle and 6 is going to be an obtuse angle. So those are obviously not going to be the same. They're not going to be congruent. But instead what's true here is that they are going to add to 180 degrees. The fancy word that we like to use there is that they are supplementary. Okay, and that's a tough one to spell, but supplementary means that they're going to add to 180 degrees. So corresponding angles are going to be congruent. Consecutive angles are going to add to 180 degrees. Last two, we have alternate interior angles and alternating exterior angles. So again, to review what these angles are, again, I have my two parallel lines, so line M and line N. Again, to show that they're parallel, just place those little arrows on the lines. You then have the line that cuts across, call that T. T is my transversal. So to give a pair of alternate interior angles, again, interior means they're going to be between the parallel lines, but alternate means that they're going to be on opposite sides of the transversal, but remember, not adjacent to each other. So to give you an example here, kind of using the same numbers from my previous drawing, I'll say here angle 3 and angle 6. 3-6 Mafia, as always, it's going down. So angle 3 and angle 6 would be alternate interior angles. Okay, now what's so special about alternate interior angles? Very similar to corresponding angles. Alternate interior angles are going to be congruent to each other. And again, congruent, fancy way of saying same. So here we would say is that angle 3 and angle 6 are congruent. So alternate interior angles are always going to be congruent. The ones that I did leave out of this diagram, and that would be angles 4 and 5, since they are also alternate interior angles, these two would also be congruent. Now, key thing here is that 3 and 6 equal each other, 4 and 5 equal each other, but that does not necessarily mean that 3 and 4 are equal, nor that 5 and 6 are equal. So know that they have to be alternate interior angles to be congruent or equal in measure. And then lastly, we have alternate exterior angles. So alternate exterior angles, very similar to alternate interior angles. I have M and M again as my parallel lines. And then I will have my transversal T that cuts across. To make them exterior angles, again, I want to look at the angles on the outside. So to use the numbers that I had before, I would say here that angle 1 and angle 8 would be alternate exterior angles because they are on outside of M and N, and they are on opposite sides of the transversal, and again, not next to each other. They are not adjacent to each other. So what is so special about alternate exterior angles? I kind of use the same color here, trying to color coordinate things. But when I look at angle 1 and angle 8, and I can also look at angle 2 and angle 7 to use my diagrams again, is just like alternate interior angles, these angles are also going to be congruent to each other, which means same. All right, so kind of in total, you have all these different angle relationships. So to summarize it, let me draw this diagram all over again, a little bit larger for you. So let's say that I had my two parallel lines. Here is M and here is N. Again, parallel means that those two lines are not going to intersect. They're going in the same direction. They'd have the same slope. And let's say that I have my transversal here, which is T. There's going to be 8 angles formed based on the two intersections. 1, 2, 3, 4, 5, 6, 7, and 8. So the best way I like to do this is kind of color coordinate things. If we start off with corresponding angles, we could do this many different ways, but corresponding angles we said are congruent, consecutive, they add to 180, alternate interior are congruent, alternate exterior are congruent, but here's what happens. Let's say that I start off first with angle 1. Okay, angle 1, let's say corresponds to angle 5. They're both in the top left corner. We know that angle 1 and angle 5 are congruent because corresponding angles are congruent. Now, I know that angle 1 and angle 2, for example, being next to each other, that they are not going to be congruent. But we do know that these two angles are technically what's called a linear pair. That any linear pair is going to add up to 180 degrees. So I'm just going to highlight angle 2 with blue. Now, using the idea of corresponding angles or anything that I got here, I know that angle 2 and angle 6 would be congruent to each other. Okay? Now, using the same side interior consecutive angles. All right, same side interior consecutive angles, let's say that I look at angle 6, which is already highlighted. I know that 4 and 6, like I said, are going to be same side interior angles. But what I said is that they are not equal, but instead they add up to 180 degrees. So I'm going to highlight 4 with red. And you'll notice that 4 and 5 are highlighted with the same color because not only are 1 and 5 equal, but 4 and 5 are also equal because they're alternate interior angles. And that would be the same thing for 3 and 6. All right, and then for 7 and 8, well, we could go to our alternate exterior angles. I know that 1 and 8 are equal to each other because they're alternate exterior angles, as well as 2 and 7. So kind of color coordinating it, here's what this means. Anytime I see, if I were to use this diagram, if I were to have two angles in red, what I know is that those two angles are going to be congruent to each other. Similarly, if I see two angles in blue, I know that those two angles also have to be congruent. Now, what does it mean then if I have a red and a blue, like let's say, for example, 7 and 8? Well, I know that anytime they're two different colors, that if I add those angles together, I should get 180 degrees. Now, if you got some crayons or colored pencils or something, you want to draw this diagram, this is a very helpful way, a little chart that you can organize all these things into one diagram. Now, our goal is we're going to try and use this to identify not only the types of angles, but knowing the relationships, we can actually find unknown angles. So in this one, it shows you we have kind of the same numbering, but different setup. But you have your two parallel lines shown here and here. You have your transversal, and you have angles 1 through 8. And we know that angle 1 is 120 degrees. So let's just highlight that in blue. And I want to know, what are the three other angles that are also 120 degrees? It says to identify these angles and explain why. Okay? So by looking at the diagram, some of you will be very good at visualizing this and understanding what the angles that would relate to 120 degrees would be just based on the diagram. But I'm going to use kind of our fancy jargon. First of all, I know that angle 5 is also going to be 120 degrees. So angle 5 is going to be a part of this list. Now the reason why angle 5 is going to be 120 degrees is because they are corresponding angles. Okay, so corresponding means that they are in the same location. Those are both in the top left corner of that intersection point. I also know, let's say, that angle 8 is going to be 120 degrees. I know that angle 8 is 120 degrees because they are alternate exterior angles with angle 1. So this angle right here would be alternate exterior angles with angle 8. And then lastly, I have angle 4. Okay, and angle 4, there's many different ways that I can do it, but angle 4, I'm going to say this, is alternate interior angles with angle 5. Okay, I can say here, alternate interior angles. Heck, I could have said vertical angles, if you remember what that is. Okay, multiple different things I can say here, but again, it's just being able to identify these special angle relationships. Because if you're able to identify, then we can use the fact that some of them are congruent or that they add to 180 to try and solve for things. So say here that I give you this diagram and I want to solve for x. Let's find the value of x. Notice that I have the parallel lines A and B in my transversal. So we are given the angle measure here of 115 degrees. Angle 4 is something we don't know. And then we have x plus 5. And our goal is to try and solve for x. Now to do this, we have to somehow set up an equation or some sort of mathematical expression that we should be able to solve for, okay? So we're going to have to use some special relationships. So first of all, we know, and I guess if you want to visualize this, you can probably see that 115 degrees an obtuse angle. You can probably visualize that that angle is not going to be the same as x plus 5 because that's an acute angle. So here's what I'm going to use. I know one relationship also to not forget is that if this is 115 degrees, that means that angle 4 must also be 115 degrees. The reason why is that those two angles are going to be vertical angles. Okay, and that's something we talked about in chapter 8. So how is this helpful in finding x? We know that angle 4 is 115 degrees. Now, how does that relate to the expression x plus 5? So by highlighting it, I just want to show you guys that notice that angle 4 and x plus 5 are both interior angles, and they're on the same side of the transversal. The technical name is that they are consecutive angles. Okay? Now, based on our chart and what we talked about, what's true about consecutive angles? Well, consecutive angles are going to add to 180 degrees. They are what are called supplementary angles. So that means angle 4, which is 115 degrees, plus the x plus 5, that should add up to 180 degrees. So by using that rule of one angle plus the other angle equals 180, I now set up a mathematical equation I can solve. Okay, now to solve this, what I'm going to do is obviously try and get x by itself. So real quick, I know they're different colors, but I do have two, God bless it, I have two numbers here that I can combine. So that would give me x plus 120 equals 180. So then if I just subtract 120 from both sides, what I would get is x equals 60. So I know then that x is 60. All right, we found the value of x. Now to just show how this relates back, if I take 60 and plug it in where x goes, I would have 60 plus 5, which gives me 65 degrees. And here's the neat thing, folks. What is 115 degrees, which is angle 4, plus 65 degrees? You betcha, folks. That's 180 degrees. So notice how it checks out in the end. All right, we're going to do a similar example here, a little bit different, but our goal again is to try and solve for x. All right, now instead of the last problem, we use vertical angles. In this example, we're not going to use vertical angles, but instead notice how I have two angles next to each other. I have 136 that's given, and then we have angle 1. So anytime you have two angles next to each other, just remember that especially since they're on the same line, they are technically a linear pair, which means that they add up to 180 degrees. So if this is 136 degrees, if I just take 180 and subtract 136, that would tell me then that that missing angle, angle 1, is going to be 44 degrees. So right away I can figure out what that angle is by using some stuff we talked about in our previous chapter. Okay, now how does angle 1 relate to the angle that's shown? And we're trying again to solve for x. Is you should hopefully recognize that those are alternate exterior angles, and alternate exterior angles are going to be congruent. Now, how do we take that idea of congruent and set up in a mathematical equation? Is congruent literally means equals. So that means that 7x plus 9 is going to equal 44 degrees. That those two angles are going to be the same in measure. So I set up that equation and then solve for x. So in this case, I'd want to subtract 9 from both sides first, which would give me 35. And then lastly, divide both sides by 7. An extra step here, I get x equals 5. Okay, so by using those angle relationships, I now know what x is. You know what? And just for funsies, if I take 5 and plug it in where x goes, I would get 7 times 5 plus 9. That is 35 plus 9, which is 44 degrees. So notice how it also checks out. So again, we're using these ideas of these special angle relationships to try and solve for things. All right, lastly, let's talk about a real-life application of this. There's many real-life applications of these special types of lines and angles in real life. Here's one using a rainbow. So this is actually what happens when you see a rainbow. Is obviously it happens after a rainfall. You have sunlight that enters into our atmosphere and it hits water particles in the air, and what happens is that the light hits the water particles and it reflects off, and based upon the angles and all that, it will form different colors. Okay, so here it says that this process makes the rainbow, and that for violet light, that the angle formed here between when the light comes in and bounces off that water molecule, that is going to occur at 40 degrees. So it's telling you right here that the angle 2 measured there is going to be 40 degrees. And using that, I want to know what is the measure of angle 1. God bless America in all of its glory. I keep doing that. So how do I know what angle 1 is? What I want to do is just use my angle relationship. So notice how this yellow line that's there is showing the ray of light that's going off the dude's head. So that's just there to show you kind of two parallel lines. So notice that these two angles are between the parallel lines. So that means that these two angles are going to be interior angles. So that means it could be alternate interior angles or same side or consecutive interior angles. And you'll notice here that this red line is forming what's called the transversal. So you'll see that one of the angles, angle 2, is above, angle 1 is below. So that means that these are alternate interior angles. So alternate interior angles, again, remember, means that they are congruent. So that means in this case, the measure of angle 1 is also going to be 40 degrees. And the reason why I know that is because they are alternate interior angles. All right, so in this section, we just focused on the special angle relationships formed between parallel lines and the transversal. All right, so make sure you jot down that little table. If you wanted to draw that diagram, go back and do that. Otherwise, good luck on the practice problems. We'll see you guys next time. Peace out.